Hello everyone and a very good morning to all of you. I hope you all are doing great. My name is Amar and in today's workshop I'll be showing you how you can turn your Raspberry Pi into an object detection Pi with 0 lines of code. So let's get started. Alright, before we start, let's talk a little about the assembly. The assembly is basically a smart lab based out of In5 since December 2014. And over the course of around 7 years, we have provided around 300 free workshops. Now, these workshops are divided into 3 categories, which are hack, code, and data science workshops. Hack workshops deal with embedded systems, IoTs, and any workshop that requires hardware comes under hack category. On the contrary, code workshops are workshops that are solely software related, like projects or workshops that include software APIs, gaming projects, etc. Finally, we have the data science category, which is quite self-explanatory, dealing with stuff like AI, machine learning, big data, data analytics, etc. Our target audience are students, entrepreneurs, and professionals. But we are more than happy to welcome anyone who is interested in technology and wants to learn about it. We focus on smart technology and its practical applications, and you can know more about us on our forum, which is members.theassembly.ae. Also, tag us on our social media. We're very active there. We are there on Facebook, Twitter, Instagram, and YouTube as well. You can check out our social media handles and keep in touch with us. Okay, so what are we going to do today? So like I said, we are going to make turn your Raspberry Pi into an object detection Raspberry Pi, but with 0 lines of code. We won't write any single line of code for this entire workshop. It's going to be a code-free workshop. So we'll be using the Edge Impulse. So basically, Edge Impulse is a development platform that allows us to develop machine learning models for embedded devices. Now, this is the sole reason we'll be able to do the 0 lines of code thing, and it also makes it very easy to you to upload your data for your data set. You don't need to collect data and upload it onto your computer. You can just simply use your phone, take images, and that's it. Your data set is complete. You have a data set. Then we'll be connecting it to Balena Cloud, and then we'll be getting a Raspberry Pi image, and we'll put that onto Raspberry Pi, and we're good to go. So we'll go through the whole process in a while. Let's look at the requirements. The requirements are pretty simple and straightforward. So we just need a Raspberry Pi with a memory card, and we need some sort of camera, either a Pi camera or a USB camera. Webcam would work. Okay, we don't need any HDMI cables or external monitor, external keyboard, external mice. And that's another advantage of using Edge Impulse and Balena Cloud. So everything would be accessible via the dashboard, and we don't have to use any external keyboard, mouse, or monitor to look at what's going on. So we can do any and everything from the terminal or the dashboard itself. So enough of the talking. Let's get started. So enough of the boring stuff already. Let's go ahead onto our browser and actually start making our object detection Pi. So on your browser, you go to edgeimpulse.com. So once you are there, so basically Edge Impulse is a web platform that enables us to create machine learning or do machine learning on the edge devices. So if you're not already signed up for this, go ahead and sign up. It's a very simple sign up procedure. Just asks you for a couple of things, but I have already signed in. I have already signed up, so yeah, I just logged in. So here we are with the dashboard. So this is how it will look when the first time you arrive at this page. So now what we want to do is we want to collect data for our machine learning program. So every machine learning model needs data that it has to train on. So for our data collection, it will be very simple thanks to Edge Impulse platform. It will be as simple as just clicking pictures from your phone. So what we need to do is we need to go to the data acquisition tab, and over here it says that no data has been collected yet. So just click on collect some. Let's collect some data, and it gives you a bunch of different options. So this is the normal way that usually we used to do, like training, when training normal models on TensorFlow or anything. You give your models in, like, you give your upload your training data. So this is the legacy way, but we will be using this one, which is using your mobile phone. Now there are a bunch of other options available. You can choose to do them as well, like, but for now we're just using this one. So let's click on show QR code, and now let's head on to our phone. So what we'll do is we have to just scan this QR code, and it will automatically open the web, and let's see what happens next. Here we are on our phone. We just scanned the QR code, and we are on a web page which says smartphone.edgeimpulse.com/index.html. Now it says that our phone is connected, and it says you can collect data, right? So click on collecting images, and it should ask you for camera permissions. Yes, there it is. Now give access to the camera, so that's absolutely fine. Alright, so now over here it opens up the camera and it allows you to take pictures. So whenever you click capture, it takes images. So the optimal amount of images should be around 30 to 50, but the more you take, the better it is. Now one more thing that I would like to add is this label category. So this is basically the label that you want to give to your data. So in our case, we'll be detecting a Raspberry Pi, so we'll train the model to detect a Raspberry Pi, an Arduino, or a pencil. So basically you can do whatever you want to, like whatever you want to train your data on. So just enter a label, and so yeah, a good thing is the category, so it automatically splits into 80 and 20 different 80:20 ratio. So why is that? Because it will use the 80 part to train the data and 20 to test the images, test the data, the model. So yeah, that's pretty much it. So let's just capture some images, and make sure you capture images from different angles, right? Not from the same angle. So take like multiple different angles, images from different angles, and just make sure that the lighting condition is not very bad. So yeah, let's just collect images now. Yep, so I'll just continue taking some more images, and as you see, like, the images get uploaded onto their cloud very quickly, so that we can just use them to train our model. So I'm taking images from quite a different angles and weird angles sometimes as well, because to make sure that it has a good idea of things. And so I have taken 47 pictures up to now. So I think that should be good enough for at least training purposes. So let me do the same with the Arduino and the pencil, and then we'll go to the next step. One thing to note, however, is that when you change the object, let's say you've switched from Raspberry Pi to Arduino, so you want to go here and change the label to Arduino. I mean, even if you forget to do this, we can always do it after this, but it's always good to change the label when you're changing or taking different images of different objects. So we'll follow the same process for the Arduino as well and take some pictures. Alright, so now we're done collecting our data. So what we'll do now is, so it says it's connected, we'll just close this, and you can see that under the collected data tab, you have a list of all the images that you have taken so far. So all these images along with the labels. So as I was saying, like, if you forget to change the label of anything, so just let's take this for instance. So this is a picture of the Raspberry Pi. So if you want to change the label or anything, so you can click on edit label and then change the label. So that's something you can do. And if for instance by any chance you forget to select the label and the label turns on to unknown, so you can select those many devices, like those many images, and then you can edit the labels for them. So it's very easy, and also you can change it, like move it to a test set, but that's not something we want to do because we have already kept it so that 80% of the images go to the training data and 20% go to the testing data. So this is our training data. So it says that we have collected over 101 total number of images, which is not very much, like if we compare to the traditional model. So detecting 3 items and 101 images are not that much. So yeah, that's a very nice way to collect our data. So we've collected our data pretty quickly, and it says that there are 35 items for the test data. So these will be used to test the accuracy of the model. So again, you can change the labels or go through the data and see what images they are and all that, and you can manipulate them. So that's one thing. Okay, now let's head on to the impulse design. So click on the impulse design, and there you'll see an option of create impulse. Now once you're there on the impulse, now what basically impulse does is it takes your data and then extract features out of it that will be used to identify the object that you're trying to detect. So basically we need to add a processing block and a learning block. So in the processing block, you have to define what type of data that you are providing. So it can be either audio, spectral analysis, raw data. But in our case, we have taken images, and that's the type of data we want to feed into our model and then train the model on. So we'll choose image. So we'll click on add. Then learning block. So learning block is basically what defines what type of method it used to extract features. So it can use transfer learning, neural network, or k-means anomaly detection. But for our purposes, we'll be using transfer learning because the data set is pretty is small. So transfer learning works well with small image data sets. So we'll just use that. So we'll click on add. Now once we're done with this, what we'll do, it also shows us that the output features, we have three. We have Arduino, Pencil, and Raspberry Pi. So that's, these come from the labels that we have defined. So we'll click on save impulse, and right, so it says successfully stored impulse. Thing that we want to do. So once we are done with the defining what type of data we have and what type of learning model or training model we want to use, either transfer learning or neural networks, we can head on to the image tab from the left over here. So this shows us what's the image and the raw features, and this is basically what will extract the features from the images. So here we'll go to the generate features, and it tells us that the data in the training set is 101 items and there are 3 classes. So basically that means there are 3 labels or 3 different types of objects that can be identified using the given data set. So in our case, it's the Arduino, the Pencil, and the Raspberry Pi. So we'll just go ahead and click generate features. This process will take some time depending on the number of images that you have provided. So it might take some time if your data set is larger, and yeah, so it's gonna take some time. So okay, so actually it didn't take as long as I had anticipated. It's pretty quick, like it just took a few seconds. That's what it did. So yeah, so it says that processing times 4 milliseconds. Okay, we can. So this is the graph that it has given us. So it's a the pencil is over here, this part of the graph, and the Raspberry Pi and Arduino are a bit mixed up. So that means we will have some trouble identifying these two because these two are pretty close together. That means the model does not very clearly know which is Arduino and which is Raspberry Pi. Again, this can be improved by taking better quality images and with proper lighting condition, and more images would also help sometimes. So yeah, but like for demonstration purposes, it should work fine as well. So now let us head over to the transfer learning tab. So over here we define the parameters for our training So we'll just keep all these default as they work fine, but if you want to change them, feel free to change and play around with these steps to uh, change the or improve the training accuracy. Then yeah, just make sure you turn this on. So click on data augmentation, so it randomly transforms data during training. So yeah, this will help us in increasing the improving the accuracy, and then finally we can hit start training. Now again, this training process will, and over here on the right you can see the actual output that's of the training. So it will be in real time, so as the training is going on you can see what's happening. Again, this will take some time depending on your image, the size of data set, and also yeah, we just need to wait for this. And once it's done, it will show us an analysis of what's the percentage accuracy of the data, what's the type of data that was recognized or misrecognized. So we'll see that in a moment. All right, so now our training is completed. So as you can see that it says that the model has an accuracy of 76.2% with a loss of 0.47. And this table is something that's interesting. So it says that it's able to recognize Arduino, pencil, and Raspberry Pi. So accuracy of Raspberry Pi is very low. It's 58.3%. And sometimes like 41.7% of the times it says that the model predicts that the device is Arduino, whereas actually it's a Raspberry Pi. Now the most obvious reason for this is because my lightning condition was not the best one when I was taking images. So I would recommend taking images in a well lighted room and proper images. So that should help us with like getting rid of these kind of false positives. So yeah, and then there is a graph down as well which you can use. Like it tells you when Arduino is correct, pencil is correct, and when Raspberry Pi is in. Yeah, that like visually it helps to visualize the data and where it's going wrong and where it's correct. So the good thing however is the fact that it's able to detect pencil with 100% accuracy. So at least when we are testing out the model, we'll know when it detects the pencil and the other model. So let's go and test our model now. Let's go to the model testing tab over here. Now over here these are all the test data, so we can just click on like select all from here and then classify selected. It will run the task and it will test the model. So looking at the confusion matrix from the last time, like the transfer learning tab, it seemed like it's a good idea that we should probably remove some images of the Raspberry Pi or take few other images with proper lighting condition to improve the accuracy of the model. But okay, even with this we got an 88.57% accuracy, which is pretty good given the number of images that we took and the time it took to make the model. So I mean this is not something that you could deploy in real life right now, but yeah, if you take your time and take proper images and with proper lighting background and take like a number of images, different images, like more than 50 or something, then definitely you're gonna get a higher percentage accuracy, and that is something that will be very great. So yeah, so the green ones that you see here are the images that it says that it has recognized correctly. So it has, these were the pencils, so all the pencils are correctly identified. Arduinos are also correctly identified. Okay, so for one Arduino it's uncertain, and one Raspberry Pi it's uncertain. So yeah, again that's because of, as we saw in the confusion matrix, that the model has some level of difficulty in identifying properly whether the object is a Raspberry Pi or an Arduino. So that, like I said, could be something that we can. But yeah, the good thing is we got a high accuracy, which is 88.57%. So that's good enough for, at least for now, like for us to try. So the next thing we're going to do is we're going to connect it to BalenaOS, CloudOS, and then put it onto our Raspberry Pi and actually test out that part. Okay, so let's deploy our model. Go to the deployment tab, and here you can deploy your impulse or your model to any device. Now we'll choose the WebAssembly, and then we'll select the quantized option and then click on build. Now one good thing about this is it says that it will allow you to, like, it will optimize the model to use 50% less memory but still have the same accuracy. So this is a great option for like devices that have limited memory resources, like embedded devices like Raspberry Pis, and also this is a great option. And you can also change the optimizations and click the unoptimized one. It's up to you. You can play around with this, but this one works pretty well. So yeah, we'll just go ahead and click build model, and it should build within a few seconds or so, and we should be ready. Now the next step that we're going to do is we're going to create an account on Balena Cloud, and we're going to link that to our Edge Impulse and deploy, and then get the cloud, or not the cloud, sorry, the Raspberry Pi image, the Balena, and flash that image onto our Raspberry Pi and test the model out. So our build has finally been completed now, and we will head on to Balena Cloud. Make sure you have a process, and once you're signed and logged in into that, you should see a dashboard similar to this. Not exactly similar, but you should see something over here. So you should go to where it says, this is where you'll have it. So you'll have to create a new application first. So now you can create an application by clicking on the link in the description below. So there should be a link that will allow you to create an application, and it will take you to the step that's wait, let me show you. So you'll get a similar when you click on the link, you'll get a similar type of pop-up opening, except that it will, over here it will say TinyML application, and everything would be filled in for you, and you'll just say deploy to application. So that's the part that will be pre-done for you. So you want to log in. Make sure you log in first and then click on the link. So it will take you to this, and then you will be able to see an application which is Balena Cam TinyML, this one. Now once you have this application, you'll have the option to add devices. Now by default devices, but now I have been trying it out, so I have a few devices over here. So you can go ahead, click add devices and add device. But before we do that, we need to do a couple of things. So we need to head on to service variables, and we need to add variables. So variables with name and value over here. Okay, and make sure that the service is Edge Impulse Inference, right? And these are the name of the service variables that you need to have. Need to have EI underscore API underscore key and EI underscore project underscore ID. So this is basically the project ID and the API key from the Edge Impulse. Now where you'll get these values is from the Edge Impulse. Okay, let's head to the dashboard section. Once you're there, if you scroll down, the part where it says project info, you have the project ID right there. So you can just copy that and paste it over there. Again, for the API key, you can go into the keys section, and there is your API key. You can copy that from here. The thing is, if you copy it directly from here, it won't give you the complete one. However, if you hover over it, it will show you the complete. So yeah, you can just copy or type it in, that's up to you, but you need to copy and paste it over here. So once you're done with that, then the process becomes really simple. Now go to our devices, add a device, right? So choose whichever version of the device you have logged. They have a lot of devices. They have Orange Pi, Jetson Nano, Revolution Pi, all the different types of Pis and every other embedded system they have it. So you choose whichever you want. So let's say you have a Raspberry Pi 400, Pi 4, whatever you have, you choose it from here. In my case, I'll be using Raspberry Pi 3, and select the OS type, keep it to BalenaOS, and I'll just leave the version as default. Make sure you select the development, and in case you only require, or your device will always be plugged into Ethernet, which I guess not will not be the case for most of the people, so you will choose Wi-Fi plus Ethernet. So over here you'll add your Wi-Fi name, and over here you'll add your Wi-Fi password. Now there's no need to go and change the advanced settings, so just add your username here and password here. So this will allow your, and then this grayed out button which says download Balena OS will be available. I'm not going to do it because I've already done it, so uh, this will be available for you. So you'll download this OS now, and once you download it, you'll flash it to your SD card. I'll show you that process as well. So yeah, and don't worry, even if your network is hidden or your Wi-Fi network is hidden, it will still work a charm. So you just put your SSID and password here and it will work just as well with you. So basically this will give you an image, ISO image for you to Raspberry Pi. So rather than the original Raspbian, it's a different image that will have your machine learning model running on it. So yep, that's pretty much it. So then we downloaded it, and I'll see you in the next part where I actually flash it onto the SD card. Right, so now that we have downloaded the Balena OS image, let's go head on to our Balena HR and select flash from file. Then you choose wherever you have kept the file. The entire zip file will just work as well. So click open, and then over here you will select your SD card. Now I don't have any SD card plugged in right now, but once you have, you'll have the SD card show up here. You can select that and hit flash. Now this will usually take no more than 2 or 3 minutes. So after that it'll be done. So yeah, once you flash the memory card, just put it into your Raspberry Pi and just plug in the Raspberry Pi. Now the good thing about using this kind of setup is that we don't need to have external monitors or keyboard or mouse to control your Raspberry Pi. Balena OS will give you everything on the dashboard itself, so you can have the terminal access and everything itself. You don't need to do anything except for plugging the Pi in. So once you flash the memory card, just plug in the Pi, wait for around 3 to 4 or 5 minutes till the device shows up on your dashboard. So over here on the dashboard, a device should show up. So when we go back, let me just go back to here, and as you can see it says online, right? So at first when you plug in, as soon as you plug in, it won't show up, so just leave it for like 5-10 minutes. 5 minutes would be fine, and then after that time it would just show the status as online. And once it's online, it will update. Now the updating part is what will take a lot of time. It will take around 30 minutes to 45 minutes depending on your internet connection and everything. So it will update the entire system, and once it's done, this is where you will be able to access device. Now this over here is the actual CPU temperature, CPU usage, temperature, memory usage, storage of the Raspberry Pi. Now notice that I am not even connected to the Raspberry Pi. This is only via internet, so I haven't connected any HDMI cables to the Raspberry Pi yet. I'm still able to do everything. Now this is my local IP address. I'll just copy that and head on to another video and paste this IP address and hit enter. So it's as simple as that. Now over here we've got our machine learning model that will be able to detect 3 devices: pencil, Arduino, and a Raspberry Pi. So whatever model you have trained it on, whatever data set, it will be able to detect that over here. I'll just point the camera to the Arduino and see what it says. Okay, so it's saying that it's around 70-80% sure, 83% sure that it's an Arduino. Now let's move on to the second one, which is the Raspberry Pi. Let's place it there. And there is a bit of a delay between the camera and the update on the website. So over here, let me properly show the Raspberry Pi. Okay, it's still picking up the so it's around almost 100% sure that this is a Raspberry Pi. And finally, to test, we have our pencil. Let's test our pencil out. Let's see if it properly detects that. So yeah, like it's almost 90 to 93% sure that it's a pencil, so it works fine given the fact that our data set was composed of only around 101 images. This is pretty good accuracy that we have. So if we have the proper data set with lots of images from different angles and proper lighting at a very high per accuracy, and this could potentially be used to find faults in different circuits or anything. So that's where a use case of this could be. Another thing is the camera that I am using is a Raspberry Pi camera, so it does not have a very good resolution. So I would recommend you guys to use a USB webcam. That works fine as well. But even a US, as long as you don't want the detection to be as precise, like when you are checking for faults on a PCB or anything, you want the camera to be very good resolution and do the detection properly. But for our use case, this was just good enough. So yeah, so that's it for today. And yeah, all right, that's it for today's video. I hope you guys enjoyed it. If you liked our video, give it a thumbs up. If you like our content, consider subscribing to our channel so that you will be notified every time we upload a new video. Until next time, see you. Bye bye.